Okay, let's dive in. The three primary measures of central tendency that are going to be of most important to us are the mean, the median, and the mode. You may be familiar with these words already and what these terms are, and if so, that's great. But we're going to go through it just to make sure we're all comfortable and we're all on the same page. So the first of these terms that we're going to discuss is the mean. It's the thing that's commonly known as average. And I put average in quotation marks there for a reason. I'll get to that in a little bit. But the mean is basically add up all the points and divide by how many there are. Add up all your data points, divide by how many there are. You might not feel like you need a formula for this, but I'm going to go ahead and give you one anyway because it's going to come in handy for us later on this week. That first symbol I just drew there, X with a line over it, that's called X bar. And it's used to represent the mean. And the mean of any data set will be the sum of the data points lost my connection there for a second. Sorry about that. The sum of the data points divided by the number of data points. So the sum of the data points divided by the number of data points, that's how we'll find the mean. The abbreviation we'll use for it is X bar. Up next, we have the median. Oh, and if you see anything that you're not sure of, doesn't make sense as we're talking through these definitions, you make sure you ask. The median is the middle number in a data set. So it's the one that's in the middle. Now, there's a really important caveat with the median, and that is first, before we determine the median, we have to arrange the data values from lowest to highest. Because it can't just be, well, these data points were written down in some random fashion, and the medians, whichever one happens to be in the middle. No, it's more systematic than that. It's once the data values are arranged from lowest to highest, then it's the one in the middle. Finally, the mode. The mode is the most common data value. So whichever one occurs the most. I do need to mention a couple of things about that though. Let's say we had a data set that was like 3, 4, 4, 5, 5. If you look at that data set, you're thinking, well, which one's the mode? Well, 4 and 5, those both occur the most. So which one's the mode? In a case like this, we would call it bimodal, and there would be two modes. The 4 and the 5 would both be modes, and we would say this was bimodal. The natural thing to think next is, okay, well, what if you also had this? And now you have 3 modes. Okay, we're not going to call it trimodal. Once we get to this point, if we have 3 or more that are all represented the same number of times, if that happens, then we just say there is no mode. There is nothing that occurs more than anything else. So if there's 1, it's the mode. If there's 2 that occur more than everything else, we're okay with that. We'll call it bimodal. If there's 3 or more that occur more than everything else, then okay, never mind. There's just no mode in that case. Last thing I want to mention here, and this is really important, is this. Kind of leans back into what we saw at the end of last week with the idea that you can use data to sort of share your point of view. Technically, when we're talking about statistics, any one of these can be called the average. Now, daily conversational walk around language, average means add them all up and divide by how many you have. But statistically speaking, if you're going to add them all up and divide by how many there are, you'd call that the mean. The word average can actually be used to mean any one of these numbers. The average could be the mean, the average could be the mode, the average could be the median. So when you hear like average house price, they could be talking about any one of these three, and it's totally legitimate. Much better to use words like mean, median, and mode because they're much more descriptive than the word average. Any questions on that before we look at a couple data sets? Okay, very good. Thanks, Nicole. All right, so if we want to find the mean, median, mode, and range, that's a new word for us. It's a very simple one that I'll mention last in our calculations here on this page. So find the mean, median, mode, and range for the following data set, and then round the mean to the nearest hundredth. So we're supposed to find the mean, the median, the mode, and the range. So let's go ahead and find the mean first. Our mean here, that's going to be, well, if I want to find x bar, that's the sum of the data points divided by the number of data points. So I'm going to add them all up and divide by how many there are. So let's see, that's 4 plus 6 plus 9 plus 3 plus 2 plus 3 plus 7. We're just adding them all up, and then we'll divide by, let's see, I have 1, 2, 3, 4, 5, 6, 7 data points here. I have 7 data points, so we'll divide by 7. Add them all up and divide by how many there are. Probably pretty familiar for you, but just in case you hadn't seen it, I'm going to go ahead and be explicit. 4 plus 6 plus 9 plus 3 plus 2 plus 3 plus 7. Looks like 34 divided by 7. We'll go ahead and divide that. And I get 4.85714. That keeps going. But in this particular case, I was told to round to the nearest hundredth. So we'll do that. That means find the hundredths place. That's 2 spaces past the decimal. That's where the 5 is. I'll look 1 space to the right of there, and the number in that position is 5 or bigger. So we'll round this up, and our mean here is 4.86. Let me know if you have any questions on that. Our mean for this data set is 4.86. Next thing we're supposed to find is the median. One thing I do not want to do is go, well, there's 7 of them. 1, 2, 3 over here, 1, 2, 3 over here. That one's in the middle. That's the median. What did I forget to do? Perfect, Xochitl. That's exactly right. Zara, Riley, probably writing the same thing down there. You're exactly right. We got to make them lowest to highest first. So the first thing we're going to do, sort of as a gut reaction, as soon as we see a data set, we're going to write it from least to greatest. So let's see here. I have a 2, and I have a couple of 3s, then a 4, then a 6, 7, and a 9. Now we've written them from least to greatest. Now we can find our median. And the way that I'll do that is just, I've got this here. I'm going to kind of section it off. I can see here that I have 1, 2, 3, 4, 5, 6, 7 data points. So I have 7 data points. Oops. And that's an odd number. That makes a difference because when I have an odd number of data points, I will have one that's right smack dab in the middle. When I have an odd number of data points, like I do here, there will be one right in the middle that is the median. And then below the median, let's see. Okay, I've got 7 data points. That means I've got one in the middle to me, the median, and I have 6 other data points. Half of those, 3 of them, will be lower than the median, and 3 of them will be above the median. So the way that this data set shakes out with 7 data points is I'm going to have 3 below the median, 3 above the median, and the median sitting right there in the middle. Let me know if Any of that doesn't make sense. And so I'll just section this off then. All right, well, 3 below the median, 3 above the median. So the median of this data set is 4. All right, we still need the mode. One thing that's kind of nice is once you write them from least to greatest and you can see them laid out like this, identifying the mode is pretty easy to do. When we look in there, we can see, well, there's only one number that happens more than the others. What's my mode in this data set? Very good, Riley. Zara, thank you very much. Lets me know that everybody's with me when y'all type those, so I appreciate it. Our mode here is 3. That's the data point that occurs more than the others. The fact that it occurs twice is not important. We're identifying which data point occurs the most. It doesn't matter how many times it shows up. It occurs more than the others, so that's the mode. Finally, the range. We haven't talked about the range yet. What the range of any data set is it's the highest minus the lowest. So it's basically how far is it from your lowest data point up to your highest? What's the range? How big is the range of your data set? And here our highest number is 9, our lowest number is 2. So the range of this data set would be 7. Are there any questions about that before we do another example? Awesome. Thanks, Genesis. That's perfect. Okay. Find a mean, median, and mode and range for the following data set. So we're going to do the exact same thing. There is one key difference here, though. This data set has an even number of data points. So it's going to be a little bit different than what we did last time as far as finding the median goes. For the mean, we're going to use the same process here. Our mean is going to be the sum of the data points divided by the number of data points. You're probably comfortable with me adding those up and writing the number down on top. If you want to see it more explicit, you let me know. But I'm going to do 12 plus 9 plus 4 plus 8 is 33, is the sum of those data points. And here I have 4 of them. So this will be 33 divided by 4, 8.25. I was told to round the mean to the nearest hundredth. Well, it already is. So that's it. Our mean is 8.25. And that's all there is to that one. The median, a little bit different here than last time now. For the median, first reaction, first thing I need to do is write these from least to greatest. So that'll be 4, 8, 9, 12. So I wrote them from least to greatest. Now this time when I look at this data set, what I see here is that there are 4 data points. And this is an even number. And when I have an even number of data points, there's not going to be one right in the middle. There's not going to be that one extra. You know, last time when I looked at it, I had 3 over here, I had 3 over here, and then that one extra was right there in the middle to be my median. Now I don't have that. Now I'm not going to have one right in the middle to be the median. There's going to be 2 data points lower than the median, 2 data points higher than the median, but there's not going to be a number right there for me to use as a median. So here's how we handle that. What we do is we still section off our data set. There's the lower half, there's the upper half, and that median I don't have in the middle. The way that I handle this is I look at this and I say, okay, the 2 data points that are closest to the middle, I am going to find the mean of those 2 numbers, and that's going to be the median of my data set. So the mean of those 2 will be the median of the data set. Philosophically, let's make this make sense. What we're after here is we want a number that represents the middle of the data set. When we had an odd number, well, this one's in the middle, obviously. There it is. Now I don't have one in the middle, but you'll notice the one that was in the middle before was between the lower half and the upper half. We're doing the same thing now. We want a number that is between the upper half and the lower half. And to identify a number that's in the middle, what we're going to do is we're going to find the two numbers that are closest to the middle, find the mean of those, and that'll be our median. So let's go ahead and do that here. So I want the mean of those two numbers. So that's going to be 8 plus 9 over 2, which will be 17 over 2, which will be 8.5. It's halfway between the 8 and the 9. That's exactly what we would expect to happen. That's exactly what we would want to happen. And so the median of this data set is 8.5 because it's the number that represents the midpoint of the data set. And we find the two numbers closest to the middle, find the mean of those, essentially what's halfway between them, and that will be our median of our data set. Any questions on that? Because finding a median with an even number is definitely different than finding a median with an odd number. Okay, I'll ask you again, what's the mode? I asked you for the mode last time here. What's our mode? Carolina, Natalie, sociogenesis, perfect. There is no mode. Nothing in this data set appears more than anything else in this data set. So there's no mode. And then finally, we were asked to find the range, so we'll go ahead and do that. What's the range? I might as well ask you. Careful, Carolina. We want to make sure when we're finding the range, we want to make sure we're looking at the whole data set. Perfect. And that's exactly right. Our range here is going to be the highest minus the lowest, which is 8. Outstanding. All right, now it's your turn to try one. Here you go. I want you to find the mean, median, mode, and range for that data set right there. If necessary, round the mean to the nearest hundredth. I'm going to make a poll for this. In the poll, I'm just going to ask for mean and median. We can talk through the mode and range together afterwards. So the poll is just going to be mean and median. So you can use the formula to find the mean, or you can kind of use your prior knowledge of what the mean is to find the mean. We'll go another, I don't know, let's say 20 seconds on this, and then we'll talk about it. Let's see what we've got. Not unanimous, but very strong agreement here. That's usually a good sign. Let's work through it together. So let's see. We want the mean, median, mode, and range for that data set. First, we'll find the mean, which is going to be the sum of the data points divided by the number of data points. And let's see, 3 plus 4 plus 8 plus 2 plus 4 plus 7 is 28. And I have 1, 2, 3, 4, 5, 6 data points. So we'll divide by 6. 28 divided by 6, I get 4.66666, and that keeps going. We were told to round to the nearest hundredth. Make sure you're careful with rounding. It's one of those things that's easy to take for granted. It's also easy to just sort of slip up and do it incorrectly. And if you've done everything right and then you round incorrectly, it's a terrible reason to lose points for a problem. You will lose points because rounding is part of our class and you're supposed to know how to do it, but it's a terrible reason. So we find the hundredths place, which is here, 2 spaces past the decimal. We look 1 space to the right. That number is 5 or bigger, so we are going to round this up to 4.67. We were either going to round it down to 4.66 or up to 4.67. We rounded up to 4.67. Let me know if you have any questions about anything we're doing. Up next, we're going to find the median. And to find the median, I want to write these least to greatest. Let's see, that's 2, 3, 4, 4, 7, 8. So there's my 6 data points written from least to greatest. In this particular case, I have 6 data points, which is an even number, which means I will not have one in the middle. Half the data points, 3 of them, will be lower than the median. Half the data points, 3 of them, will be higher than the median. Okay, so I'll section that off. 3 of these data points are lower, 3 of these data points are higher. And so my median would be right there in the middle, except I don't have a number sitting there. So what I have to do then is find the 2 numbers closest to the middle, that 4 and that 4. The mean of those will be the median of my data set. Some of you are like, well, the mean of 4 and 4 is just 4, and you'd be 100% right. Some of you are more comfortable writing it down, and that's totally fine. If I do 4 plus 4 divided by 2, that's 8 divided by 4, or excuse me, 8 divided by 2, and that's 4. And so the median is 4. Halfway between 4 and 4, we would expect there to be a 4. All right, 2 other questions I was asked for here. One of them is the mode. I didn't put it in the poll, but I'll just ask you, what's the mode? Excellent. Genesis, Stephanie, Natalie, Riley, Zara, thank you very much. Our mode is 4. It occurs more than the others. Happens to be the same as the median. That's totally fine. The mode can be 4 because it occurs more than anything else. And then finally, the range. What's the range? All right, y'all are ahead of me. I love it. 6, very good. 8 is our highest data point. 2 is our lowest, so our range is 6. That went really well, so I'm thrilled. I do have one thing I wanted to mention. It didn't come up in the last example, but I want to mention it anyway. Nobody brought up the idea that 8.5 is the median, but it's not one of the data points. Sometimes students will have trouble with that idea that, well, wait a minute, how can 8.5 be the median if it's not one of the data points? It's a reasonable question. Although nobody had a problem with the mean not being one of the data points. We were all perfectly fine with that. Same thing holds true. It's perfectly fine for the median to not be one of the data points. It's okay. It's a number that represents the middle of the data set, and halfway between 8 and 9 is 8.5. That's the median. It's not one of the data points, and that's totally okay. The reason I say that is we don't want to round it to either 8 or 9 to make it one of the data points. That's not what we want to do. We want to go ahead and leave it as 8.5, halfway between the two numbers that are closest to the middle. That issue didn't really come up here because they were both 4s, but if you get a decimal for the median, that's okay. It's halfway between the two that are closest to the middle. Are there any questions about mean, median, mode, and range? Excellent. Okay. A kind of a plot that you may not have seen before, and to be 100% fair, you might not find it to be that useful. But I want you to be aware that I want you to know how to read one in case you encounter one. And it's called a stem and leaf plot. And the example we have here is this particular data set that has what, 1, 2, 3, 4, 5, 6, 7, 8, 9 data points in it. So we've got 9 data points here, and we're going to make a stem and leaf plot out of these data points. And the way that we're going to do that is our stem and leaf plot. We are going to have a stem over here, and we're going to have leaves over here. And the stem for this particular data set is going to be the tens digits, and the leaves are going to be made up of the ones digits. Might not sound like it makes much sense yet. I promise it will. As I look at this data set, let's say I have 30, 40, 50. Okay, I have 30s, 40s, and 50s. So to rewrite this data set, what I'm going to do here is I'm going to make a 3, a 4, and a 5. And what those represent is 30, 40, and 50. Those are the tens digits of the numbers that are in my data set. And now I'm going to go through the data set and write them down here. So I have this 30. The way that I'm going to represent 30 in my stem and leaf plot is I'm just going to put a 0 right here. That's the ones digit, because I have a 3 in the tens and a 0 in the ones. So by putting it here in this row, that's how I know it's a 30. Then I have this 42. So I'll put a 2 right here. I've made 42. Now I have 37. So I'll go back down to this row that has a 3 in the tens place, and I'm going to put a 7 here. This 7 right here represents 37. And the way I know that is because it's in the row with a 3 for the tens digit. Hopefully that's making sense. If it's not, you let me know, and I'll make sure to explain it in a way that clears it up. Next is this 35, and then 44, 58, 41, 55, and another 30. And so I have this stem and leaf plot. What I have right now, though, is what we would call an unrefined stem and leaf plot. What we want to do is we want to go ahead and clean that up. We know it can be valuable to make a data set go from least to greatest. So what I'm going to do is I'm going to refine this stem and leaf plot. I'm going to rewrite it so that within each one of these leaves, they go from least to greatest. And so I'm still going to have 30, 40, 50 for my tens place. And now as I look at this leaf right here, let's see, going from least to greatest, that's going to be 0, 0, 5, 7. And then in this leaf, I've got 1, 2, 4. And finally, in that leaf, I have 5, 8. And now what I've done is I've made myself a refined stem and leaf plot. The value of that is if I have a large data set and I need to rewrite it from least to greatest, maybe I don't want to write down all the numbers. Instead, I can use this as a shortcut. I can put the tens digit here, I can put the ones digits over here, and it's a shortcut way of writing a data set. Something a stem and leaf plot does that's kind of nice is it sort of makes a horizontal bar graph for us where we can see there's more 30s than anything else. We don't use a whole lot of horizontal bar graphs in our course, but sort of embedded in a stem and leaf plot is sort of a horizontal bar graph there that it's easy to see at a glance. There's more 30s than anything else. If I wanted to find the median of this data set, let's see, there were 1, 2, 3, 4, 5, 6, 7, 8, 9 data points. So let's see, if I have 9 data points, that's an odd number, so there will be one right in the middle, and there's going to be 8 other data points. Of those 8, 4 will be lower than the median, 4 will be higher than the median. And so my 9 data points would look like this: 4 lower than the median, 4 higher than the median, 1 right in the middle that is my median. And so I could count from the bottom. 30 here is my lowest number. 1, 2, 3, 4, that's the bottom half of the data. Counting down from the top, I've got to be a little bit careful here because I go 1, 2, 3, 4, because I'm counting from the top down, right? 58, 55, 44, 42. There's the upper half of the data, and then I can see that the median is this 41 right here. So you may love stem and leaf plots and think, hey, that's pretty slick. You might think, yeah, that's too much trouble for me. Either way is fine. You don't have to love them. I do want you to understand that if you see a data set presented in this way, what it is you're looking at. And what you're looking at is, or here's our tens digits, and these leaves contain our ones digits of the numbers that are in our data set. Are there questions on that before I have you practice by making a stem and leaf plot? All right, here goes. I'm not going to really make a poll for this because I'm not exactly sure how I would go about that. But I want you to take this data set right here and make a refined stem and leaf plot out of it. I'll give you a little time. We're not in a hurry on this. And again, not the most important topic we're going to cover in class, I'll be honest. But I do want you to understand what a stem and leaf plot is in case you encounter one at some point. I don't know if you've had enough time yet. Probably. Let's go ahead and kind of go through this one together. If you're still working on it, that's fine. If you see something that's you're not sure where it came from, it looks different than what you have, and you want to ask about it, you just ask away. All right, let's see. So let's see, I have 60s, 80s, 70s. So not all stem and leaf plots just have 3 tens digits, but the ones we did today happen to. That's fine. 60s, 70s, and 80s. And so I have 67, 85, 73, 63, 74, 84, 61, and 72. I have 1, 2, 3, 4, 5, 6, 7, 8 data points. That's how many I have in my plot, so I feel pretty good about it. Now I need to refine this thing. 60s, 70s, 80s, and let's see, that's 1, 3, 7, 2, 3, 4, 4, 5. And so that would be my refined stem and leaf plot. The key here with reading a stem and leaf plot is if you are asked, what does this 2 represent? It represents the data point 72. And we know that because it's in the row that has 7 in the stem. Hopefully that makes sense. If it doesn't, if there's anything about this that you aren't sure of, you just let me know. No, that's a coincidence, Zara. It's an excellent question. Just a coincidence. It's just, you know, when I made up these data sets, I didn't really think about the fact that both of them had that happen. So yeah, just a coincidence. Excellent question though. Good thing to notice. But yeah, just that's just random chance. Yeah. Yeah, in the way that I made up the data set. Okay, we're gonna go turn our attention back to mean, median, and mode. But before we do that, I want to talk about repeated addition just a little bit. Repeated addition is if we need to add the same number over and over and over and over and over again, we're probably not going to do that. And what I mean is, if we were supposed to add 5 plus 5 plus 5 plus 5 plus 5 plus 5 plus 5, chances are you wouldn't, go to your calculator and do 5 plus 5 plus 5 plus 5 plus 5 plus 5 plus 5. Instead, you'd come up with a shortcut for that. And the shortcut that you would use for repeated addition is just to multiply. If we wanted to add 7 5s together, we're not going to add them all up. Instead, we're going to multiply. We're just going to do 7 times 5 and get 35. And if you're thinking, yeah, no kidding, that's good. That's good. That's where I want you to be. So with that in mind, and continuing our study of mean, median, mode, and range, I want to look at frequency tables. And sorry about that. That should be lined up under frequency, but we can work with it this way. A frequency table is a way to present a data set when there's a lot of repeat values. So what a frequency table is it's a way to show a data set when there's a whole bunch of values that occur over and over and over again. Here's what I mean by that. The number of students in classes at a school was counted with the following results. So the principal's got a clipboard. He's walking up and down the hallway, looking in the room, counting how many students there are and putting it on the clipboard. And the number of students in the class was 15 students. How many times did that happen? That's what the frequency column represents. It happened 3 times. Frequency is how many times did this data point show up in the data set. That's what this frequency column is all about. And so principal's walking down the hall some more, and there's 22 students in 7 different classrooms, 28 students in 5 different classrooms, and 40 students in 2 of the classrooms. And so this is our data set. Don't write this down if you're writing. What this data set is exactly the same as if my data set was given to me and it had 15 3 times, it had 22 7 times, it had 28 5 times, and it had 40 twice. But instead of writing out all of those individual data points, because they occur over and over and over again, instead, we've just put the data into a frequency table. It's really important to note that our data points are over here and the frequency is over here. And we're going to be consistent with that. We are going to have the data points on the left and the frequency on the right. There's not going to be any intention to trick you into, well, yeah, but which one's the frequency? It should be very obvious which one's the frequency. Okay, so in this frequency table, if I want to find the mean, the median, the mode, and the range, what I need to do to find the mean is add them all up and divide by how many there are. Again, what I would not expect you to do when finding the mean here is to say, all right, well, my mean is going to be 15 plus 15 plus 15 plus 22 plus 22. This is where that, instead of repeated addition, we're going to use multiplication as our shortcut. If I want to find the mean here, what I'm going to do, instead of doing 15 plus 15 plus 15, I'm just going to multiply 3 times 15, because that's how many I have in my data set. So if I want to find the mean here, I'm going to have 3 times 15, because there are 3 15s in my data set, plus 7 times 22, because there are 7 22s in my data set, plus 5 times 28, plus 2 times 40. Then we got to divide by how many data points I have. This is a really important question here. It's okay if you don't get it correct. How many data points do I have? Be very careful. "17 and 4 are the 2 answers I was kind of looking for there. So thank you, Genesis, Escadar, and Zara. So while it is true that I have 4 different numbers in my data set, because this one happens 3 times, and this one happens 7 times, and this one happens 5 times, and this one happens twice, I don't just have 4 data points. I'd have 4 data points if these only occurred once each, but that's not what happened here. Instead, if I want the number of data points in my data set, I'll find the sum of the frequencies. Perfect, Escadar, that's awesome. So 3 plus 7 would be 10, plus 5 is 15, plus 2, I have 17 total data points. And that's really important for us to know when we're finding the mean and when we're finding the median. So I have 17 total data points. There are only 4 different numbers that show up, but because they repeat, I have 17 data points in my data set. And then we'll go ahead and divide by 17 when finding the mean. So continuing here with our work on finding the mean, we'll have, let's see, 3 times 15, that's 45. 7 times 22 is 154. 5 times 28 is 140. And 2 times 40 is 80. And that all gets divided by 17. Now we'll add those up. 45 plus 154 plus 140 plus 80 is 419 over 17. Now we can divide. 24.6470. And that keeps going. We were told to round that to the nearest, let's see, what did it say over here? 100th. So we'll round to the nearest 100th. 100th place is 2 past the decimal, so we'll find the 100th place. We'll look 1 space to the right. That's 5 or bigger, so we're going to round this up. And our mean here is going to be 24.65. Really important. The most important thing here in finding the mean is recognizing we have 17 different data points, not just 4. That's the absolute critical piece in there. The total number of data points we have will be the sum of the frequencies in our frequency table. I'm going to hold off on median for just a minute. Instead, I'm going to do mode and range. Mode is really easy to spot in a frequency table. What's the mode here? Very good, Genesis, Natalie, Riley, perfect, excellent. The mode is the one that occurs the most. Well, I look over here in the frequency column, and I can see that there are 3 of these, 7 of these, 5 of these, and 2 of these. Well, let's see. The one that there were 7 of, that's the one that occurred the most. And I'm really impressed that you all said 22, because sometimes students will say 7 because that is the highest frequency. But what that does, this one tells us which one is going to be the mode. This is the one that occurs the most, or this is the one that has the highest frequency, and the data point that occurs the most is the 22. So that was really good of y'all to recognize that the mode here is going to be the 22. The fact that it occurs 7 times doesn't really matter. It matters that it occurs more than the other data points. But the fact that it occurs the most tells us that this one over here, the 22, is our mode. Range is easy to find also. What's our range going to be here? Very good. You guys are doing fantastic with this. I'm thrilled. Frequency tables aren't always easy for students to pick up on, but the responses I'm getting are terrific. As long as everybody's with the folks that are commenting, that's terrific. If you're not seeing the same things that they are, please ask questions. So our range here, well, our biggest data point is 40. Our lowest data point is 15. So we'll just subtract. 40 minus 15 is 25. And that's our range. All right, I saved median for last because honestly, I think finding a median in a frequency table is probably the most challenging thing we have in class today. Finding the median from a frequency table. All right. When we went through and did the mean, we found out that we had 17 data points. And that's an odd number. That means there will be one data point sitting right in the middle. So I'll have one data point right in the middle, that's my median. And let's see, that means there would be what? 16 other data points. Which means 8 will be lower than the median and 8 will be higher than the median. I want to go through this slowly and carefully, and you tell me if you have questions. But my 17 data points in my data set are going to be structured like that. Because it's an odd number, there will be one right here to be the median. And then there's going to be 16 other data points. Half of them, 8, are lower than the median. Half of them, 8, are higher than the median. How are we doing so far? If anything's a question at this point, you let me know. Basically what I need, where I need you to be okay right now is just that right there. Okay, terrific. All right, so what that means is this. If I have 8 data points that are lower than the median, if I start counting these from least to greatest, and I'm sorry I don't have a lot of space down there, I've kind of boxed myself in a little bit. You know what, I'm gonna move that up here. I have 8 data points that are lower, 1 in the middle that's median, and 8 data points that are higher. So I'm gonna put it there. When I start counting these from least to greatest, I'm gonna have data points down here. I'm gonna have the first one and the second one and the third one and the fourth one. And then the first 8 data points that I count are all gonna be lower than the median. And then the 9th one that I get to, when I'm going from least to greatest, that's the one that's going to be in the middle. Because there are 8 data points lower than the mean, the 9th one I get to is going to be my median. I said mean, I'm sorry, median. All right, so let's take a look at what I have then. The data points I have 3 of these 15s. So that's going to be data points going from least to greatest. Data points 1, 2, and 3 will be 15s. The first data point is a 15. The second data point is a 15. The third data point is a 15. And then I have 7 data points that are 22s. And that'll be the 4th, 5th, 6th, 7th, 8th, 9th, and 10th data points. If I wanted to go ahead and keep listing them, some of you are like, okay, you're done. You don't have to go any further. That's great. But I'm going to go ahead and list the rest of them just because. Then I have 5 data points that are 28s. From least to greatest, these would be number 11, 12, 13, 14, and 15. And then I have 2 data points that are 40s. That would be 16 and 17. So as I'm counting from left to right, from least to greatest. I'm sort of imagining here that I've listed them all out, least to greatest. The first, second, third, then fourth, fifth, sixth, seventh, eighth, ninth, 10th, 11th, 12th, 13th, 14th, 15th, 16, and 17. That's all my data points. So once I've got these listed out, which one was I looking for? I was looking for the 9th data point from least to greatest. So what's my median here? Outstanding. Very good. Stephanie, Zara, Escadar, Riley, Toto, perfect. I was looking for the 9th one from least to greatest. The 9th one happens to be a 22. So the median of this data set is 22. The number that would be in the middle is 22. Let me know if you have any questions on that before I have you try one. Okay, let's go. The number of animals at different animal shelters are as follows. We have 20 animals at 5 shelters, 50 animals at 4 shelters, 100 animals at 1 shelter, and 900 animals at 1 shelter. Find the mean, median, mode, and range for this data set. Like I did before, I'm just going to put the mean and median in the poll, and we'll talk about the mode and the range. So I'll make a poll for this, find the mean and median, and we don't have to be in a hurry. I can give you some time to work on this one. One thing I'll say about this poll, kind of like some of the others, is if the numbers you come up with aren't in there, pick what's closest to yours. That'll let me know that you've had enough time to work through it. So while we're after those 4 values, you go ahead and find all 4, and then when we talk through it together, we'll do all 4. We'll do the mean and median as poll results, and then we'll talk about the mode and range together, and you can let me know what you found for those. We'll go another, let's say, 20 seconds on this, and then we'll talk through it together. If you need more time, you can let me know that. All right, let's see where we are here. Not unanimous, but darn close. That's really good, because finding the median is something that is sometimes a hurdle for students, but it seems like we're doing great. Okay, so let's take a look at this together then. The first thing we want to find here is the mean. So the mean here will be, let's see, I have 5 data points that are 20s, so we'll do 5 times 20. 4 data points that are 50s, so we'll do 4 times 50. 1 data point that's 100, and 1 data point that is 900. And we need to divide by however many data points we have. And be careful here, it's not just 4. We need to add up our frequencies. 5 and 4 is 9, 10. It looks like we have 11 data points in this data set. So when we go to find the mean, we'll need to divide by 11. And so let's see, what does that give us here? That's 5 times 20 plus 4 times 50 plus 1 times 100 plus 1 times 900. If you see any numbers that you're not sure of or you don't understand where they came from, you just ask, and we'll add those up. 100 plus 200 plus 100 plus 900. 1,300 divided by 11 is 118.18181818. And that keeps going. Oh yeah, I didn't say it out loud, but I guess you picked up on it from the poll. When we're looking for our mean here, we're going to round to the nearest whole number. It's not something we do that often, but it does come up from time to time. Whole number means the ones place. So we'll find the ones place. We'll look 1 space to the right. That number is 4 or lower, so we'll round this down, and our mean will be 118. Kind of makes sense to have a whole number answer here because it's animals that are in a shelter. You wouldn't have a decimal number for that. You could for the mean, it would be fine, but kind of makes sense to go to the nearest whole number here. So 118 animals is the mean number in a shelter. We'll go ahead and do median because I'm feeling like you're in a pretty good place with that. Because the median, I have 11 data points in my data set. That's an odd number. So there will be 1 right in the middle, and then there will be 5 lower than the median and 5 higher than the median. So my 11 data points in my data set, I have 5 below the median, 5 above the median in the middle. And so if I were to start counting these, then I would have 1, 2, 3, 4, 5 down here. It's the 6th one that I get to is going to be my median. And so when I start listing these out, I've got 5 of these. That would be 1, 2, 3, 4, 5. And then this would be, I have 4 of those. That's, I'll use my fingers. I got to be honest with you. 6, 7, 8, 9. This would be 10 and this would be 11. And what I'm looking for here is I'm looking for the 6th data point. The 6th data point I got to was a 50. And so the median of my data set is 50. Any questions on what we did there to find the median? I think that's probably the most challenging of the operations that we go through in these. What y'all get for mode? Which one occurs most often? 20, outstanding. I look over here at the frequency column and I see where's the biggest number? Biggest number's right here, so 20 is the one that occurs the most. That's the mode. And then the one last question that you know is coming. What's the range? 880. Perfect. The biggest data point I have is 900. The smallest is 20. I'll subtract those and get 880 as the range. I do want to say a couple of things, but before I do that, I want to give you a chance to ask any questions about any of the work we did there to find the mean, the median, the mode, and the range. Okay. Yeah, if anything pops up, you let me know. In the meantime, what I want to mention is this. I said at the beginning, well, early on anyway, that any one of these could be called the average. Average could mean any of these. And some of these are better at describing a data set than others. Clearly, the range doesn't have a ton of value in describing a data set. Range is more about, how big of a spread is there than just the number itself. I'll read that in just a second, Lorraine, I promise. So the range isn't that great at describing a data set. The mode can be, but honestly, it's just the one that occurs the most often. That might not be most representative of the entire data set, which kind of points us towards mean and median. One thing I want to emphasize about the mean, if you look at this number down here, this 118 that we got for a mean, in this entire data set, there's only one number that's bigger than 118. There's only one animal shelter that has more than 118 animals at it. If you were going to use a number to describe this data set and say, what's typical for the animal shelters in your area? It's not necessarily a right or wrong kind of thing, but I think you could make a very strong case for the median. The reason for that is if you look at these animal shelters, I have 5 that have 20 animals, 4 that have 50 animals, and then I've got 1 with 100 and 1 with 900. This is kind of a goofy number here. It's way bigger than anything else. And what happens is when you calculate the mean, this outlier, this number that doesn't really fit with the others, has an impact. What it does is the mean, because this is in there, the mean gets dragged to a much higher number than's really representative of the data set as a whole. You could think of it as if you were driving down a street in a neighborhood and trying to figure out the values of the homes. And you've got, well, that one over there is like 375,000, and this one's 425,000, and this one's 450, and that one's 385, and then at the end of the street, there's one worth $5 million. If you did the mean of those homes, you'd get some number that's, really, really big, like close to $1 million, maybe even more. I'm not sure what it would get if we added them all up, but it wouldn't be representative of what do the houses in this neighborhood really sell for. I've got this one goofy outlier, and it's important for you to note that outliers can impact the mean. In contrast to that, outliers don't impact the median. The median of this data set that we just did, it would be exactly the same if this one were 900 or if it was 9,000. Median would still be the same. One goofy outlier has no impact on the median. It's just the number in the middle. That's why a lot of times when you'll hear people talk about house prices, what they'll talk about is the median house price or median income or median salary. It's because if there's one goofy number, high or low, it can impact the mean, but the median is very stable. That's not to say the median's always the best choice. It's just to say that it's more stable because it doesn't get impacted by outliers. Okay, let me see what you had there, Lorraine. Divide the total by 2. Round to the nearest whole number, define which number of data set I need to find. Oh, yeah, that makes perfect sense. So like here, when we had 11 data points, if we have 11 data points divided by 2, that's 5.5. Make sure you round it up, and you're looking for the 6th one. And it's kind of exactly what we did here. And that's why it works, Lorraine, is because it's really the same thing we did. It's just, I guess, a little faster maybe. Here we said, all right, I'm going to take this one out. That leaves me with 10, which I'm going to cut in half, which is going to put 5 down here, and then I need to go 1 past that. And that's why your way works, is because you're cutting it in half, and then this rounding up is going to the next one. And that absolutely works. Yeah. I like it, Lorraine. That's good. And I appreciate you sharing that with us, because that will work. It's perfectly solid. It's the same thing we're doing here, just, a little bit more streamlined, I think, honestly. As long as that makes sense for the folks who are using it. That what you're doing is, I'm finding the midpoint of the data, and what I need to do is make sure that I'm getting this guy here. And that's why going up makes sense.